Good morning, everyone. I'm Nathan Reddy from EC. Topic is types of temperature transducer. A transducer is a device that converts a signal in one form of energy to another form of energy. For example, a stereo speaker converts the electrical signals of recorded music into sound. Energy type include electrical, mechanical, electromagnetic, chemical, acoustic, and thermal energy. A temperature transducer is a device that converts the thermal quantity into any physical quantities such as mechanical energy, pressure, and electrical signals, etc. Example in thermocouple, the electric potential difference is produced due to temperature difference across its terminals. So thermocouple is a temperature transducer. Types of transducer: contact temperature sensor. In this sensing element, it is direct contact with the thermal source. They use the conduction for transfer of thermal energy. Non-contact temperature sensor. In this, the sensing element is not in direct contact with the thermal source. They use principle of convection of for heat flow. Types of temperature sensors: thermocouples, resistance temperature detectors, thermistors, infrared sensors, and semiconductors. Thermocouples, two wires of different metal alloys, converts thermal energy into electrical energy. It requires a temperature difference between measuring junction and reference junction. Easy to use and obtain. And its applications are plastic injection molding machinery, food processing equipment, semiconductor processing, heat treating, medical equipment, industrial heat treating, and packaging equipment. And its advantages: simple, rugged, high temperature operation, low cost, no resistance lead wire problems, point temperature sensing, fastest response to temperature changes. Least stable, least disadvantages are least stable, least repeatable, low sensitivity to small temperature changes. Extension wire must be of the same thermocouple type. Wire may pick up radiated electrical noise if not shielded. Lowest accuracy. Second one is resistance temperature detectors. Wire-wound and thin film devices, nearly linear over a wide range of temperatures, can be made small through to have responsive times of a fraction of a second. Requires an electrical current to produce a voltage drop across the sensor. Its applications are air conditioning and refrigeration, servicing, furnace servicing, food servicing, medical research, and textile production. And its advantages are most stable over time, most accurate, most repeatable temperature measurement, very resistant to contamination, corrosion of RTD element. And disadvantages are high cost, slowest response time, low sensitivity to small temperature changes, sensitive to vibration, decalibration of used behind sensors, temperature rating somewhat rare. Thermistors. Thermistors, a semiconductor used as a temperature sensor. Mixture of metal oxide pressed into a bead, wafer, and or other shape. Beads can be very small, less than 1 mm in some cases. The resistance decreases as temperature increases. Negative temperature coefficient NTC thermistor. And most are seen in medical equipment markets. Thermistors are used for engine coolant, oil, and air temperature measurement in the transportation industry. And its advantages are high sensitivity to small temperature changes. Temperature measurements become more stable with use. Copper and nickel extension wires can be used. Disadvantages: limited temperature range, fragile, some initial accuracy drift, calibration if used behind the sensor's temperature rating, lack of standards for replacements. Infrared sensors. In an infrared sensor intercepts a portion of the infrared energy radiated by an object. Many types optical pyrometers, radiation pyrometers, total radiation pyrometers, and automated infrared thermometers, ear thermometers, fiber optic thermometers, two color pyrometers, infrasnakes, and many more. And its applications are manufacturing process like metals, glass, cement, ceramics, semiconductors, plastics, papers, textiles, and coatings, automation and feedback control, improve safety in firefighting, rescues, and detection of criminal activities, used to monitor and measure human body temperatures with 1 second time response, reliability and maintenance needs from building, heating to electrical power generation and distribution. And its advantages are no contact with the product required, response times as faster than thermocouples, no corrosion or oxidation to affect sensor accuracy, good stability over time, high repeatability. Disadvantages are high initial cost, more complex support electronics required, emissivity variation of effect temperature measurement accuracy, field of view and spot size, and may restrict sensor applications. Field of view and spot size may restrict sensor applications. Measure, measuring accuracy affected by dust, smoke, background, and radiation. Thank you.